We're on page 9 and we're going to do problem 1A. And this problem asks us to calculate P given L and given W. This is the perimeter formula for a rectangle, and L equals the length and W equals the 15. So if we substitute for L and W into this formula, 2 times L gives us 2 times 25, and W equals 15. So we've got 2 times 15. 2 times 25 gives us 50. 2 times 15 gives us 30. So 50 plus 30 give us 80. So the perimeter of the triangle is 80 if the length is 25 and the width is 15. So this is a straight substitution. We're asked to calculate P given L and W. In this equation there are 3 variables, P, L, and W. We're given 2 of them, L and W, and we're asked to calculate the third. So if we go to problem 1G, in this case again it's a substitution. Find the value of the unknown variable in the formula. So here we're given B is 18, we're given H is 10, and we're asked to calculate A. The formula is 1/2 BH, which can be written this way. So this formula here and this one are identical. We can put the 2 right on the denominator, multiply the B and the H. So we substitute B is 18, we substitute H is 10, we divide by 2, so we get 18 times 10, 180, divided by 2 is 90. Now we could have divided 2 into 18, which has given us 9. 9 times 10 would have given us 90. That would be okay. We could have divided 2 into 10 and given us 5, and 5 times 18 could give us 90. So there's more than one way to get the solution, but again here we have 3 variables, A, B, H. We're given B, we're given H, and we're asked to calculate A. Now 2D, we're told that the area is 1/2 times BH. This is the area for a triangle, so we know the height or the altitude. The area is 1/2 base times height, but we don't really need to know that for this because this is just solving for a variable. So we have to solve for B. But B is right here. It's on the right side. So the first thing we do is multiply both sides of the equation by 2 because we don't want, try to get rid of this 2 on the denominator here. So we have no fractions. So we multiply the left by 2, we get 2A, and we multiply the right hand side by 2, this 2 here, this 2 and that 2 cancels. We get 2A is equal to BH. So we multiply both sides of the equation by 2 to get rid of the fraction. Now, because we're asked to solve for B, we're just going to reverse the equation. We're going to put the left side to the right side, and we're going to put the right side to the left side. So the variable B is on the left side of the equation. Remember, we're asked to calculate for B, so we want the variable on the left side of the equation. And we're allowed to do that. If 12 is equal to 6 times 2, then 6 times 2 is equal to 12. We can just reverse an equation. So now we have BH equals 2A, but we want to solve for B. We want to solve for B, so we're going to divide the left side by H, and we're going to divide the right side by H in order that B is isolated by itself. And we find that B is equal to 2A over H. So let me repeat that again. We've got BH is equal to 2A, but we want to solve for B. So if we want to solve for B, we want to get rid of the H. How can we get rid of the H? We're going to divide the left side by the H, which we do. And then we have to do the same thing to the right side. We divide by that. Now the H is canceled, and B equals 2A over H. Now there is a way to check the answer here. And if we go back to the original equation, when we check, we always check with a more complicated side. So this is where the B is, and we're going to substitute for the B right here in the equation. And that's what I've done. I've taken BH over 2, and I've substituted for B right here. B is 2A over H. So I've taken this B and written 2A over H. I've still got the H, I've still got the 2 here, the H and the 2 here. Notice the 2's cancel, the H's cancel, and the right side of the equation equals A. If I go back up and look at the equation, the left side of the equation equals A, and so the right side equals the left side. Now let me repeat that again. I went to the right side of the equation. It says BH over 2. I'm going to substitute for the B. I solved 2A over H. I'm going to put 2A over H for the B. I still have the H and the 2 here, so that's this H and this 2 here. The 2 cancels with the 2. The H cancels with the H, and I'm left with A. The left side of the equation is A. I've shown that the right side equals the left side. (2F). In this case, we're told that A equals P times 1 plus R in brackets, and I want to solve this for R. So the first thing I'm going to do is use the distributive rule. I'm going to multiply the P times the 1, so I get P, and I'm going to multiply the P times the R, and I get PR. So what I'm doing here is using the distributive rule. I'm getting rid of the brackets. And now I'm looking for R, what R is. So what I'm doing is I'm going to isolate the PR on the right-hand side here, move the P here from the right to the left, and when I do that, I've got plus P on the right. I'm going to move it over to the left and make it minus P. This way I've isolated the unknown by itself, or the term with the unknown on this side. And then I'm going to reverse it. So I have PR equals A minus P. Remember, I want to always have the unknown on the left side of the equation. It's true that I brought it over here, but then I just reversed the equation. So I brought this over here and this part over here. Now, if I want R by itself, I'm going to divide this by P. I'm going to divide this by P, and the P will cancel on the top and bottom. And then I'm going to divide this by P. So I get R is equal to A minus P over P. So what I'm going to do now is substitute into the right-hand side of the equation now. You see I've got r here. I've solved r here, and I'm going to substitute for it on the right-hand side. So I start with the right side, the more complicated side, or the side that has the variable in this case. P, 1 plus r. I found r is equal to this, so I'm going to substitute for it right here. So the r is a minus p over p. Next, I'm going to use the distributive rule. P times 1 gives me p. And this p, when multiplied by this second term, the p here and the p here, will cancel. So I'll be left with a minus p. This p will cancel with that p. So first of all, I substituted for the r. I found r was a minus p over p. I substituted for it right here. And then I used the distributive rule. So I multiplied this times this. I got p. And I multiplied p times a minus p over p. The p's cancel, and I'm left with a minus p. Now, p, when I remove the brackets here, I get p plus a minus p. So all I'm left with is a. I go to the left side of the equation right here. I found that is a. So the left side equals the right side. So this checks that the formula here, this tells me that the formula here that I calculated was correct. So this one's a little more complicated. The algebra in it is a little more complicated. So in this case, what I have to do is solve for b. To solve for this equation for b. So I have to get b on the left-hand side of the equation, everything else on the right-hand side of the equation. So first thing I'm going to do is use the distributive rule, and I'm going to multiply a half h times b, and I get this hb over 2, and I'm going to multiply a half h times capital B over here, and I'm going to get that. So first I'm removing the brackets by using the distributive rule. So a half h times small b is right here. That's this one. And a half h times capital B is right here. So now I'm going to multiply both sides by 2, and the reason I do that is to get rid of the fraction, the 2 on the denominator. So I get 2a, I multiply this by 2, then I multiply this term by 2, and I get hb, and then I multiply this term by 2, and I get h capital B. So all I'm doing here is multiplying the left side by 2, and each of the terms on the right side by 2 in order to get rid of this 2 on the denominator. So I get 2a on the left, hb plus h capital B on the right. Now I reverse the equation so that the hb term is on the left side of the equation, because this is the one that I want to solve for. I want to solve for little b. So I'm putting this on the left side, putting the left side here to the right side and the right side to the left side. This way I've isolated the HB on the left side. Now I'm going to move this term from the left to the right and change the sign. So all I've done is move this term from the left to the right by changing the sign. Oh, at this point, I have HB by itself right here, h small b. Remember, I'm trying to get b. So if I want to solve for b, I have to divide by h. And if I divide the left side by h, I have to divide the right side by h, which I've done here. And finally, I come out with the equation that small b is equal to 2a minus hb over h. small b is equal to 2a minus hb over h. Remember, the h and the h here will cancel. I'll be left with b, and I'll be left with this term on the right-hand side. So now I go back to the original equation right here, the right side, and I'm going to substitute for the small b. That's what I'm going to do. I'm going to start with the right side and substitute for the small b. Here's the right side, and I've substituted for the small b right here. Remember, that b is this term here. So I've taken this b, substituted for it. And you'll see that the h's cancel when I use the distributive rule, and I get 2a minus hb over 2. So again, let me repeat here. I have h over 2. You see h over 2? I put that h over 2 here. I substitute for the little b right here. This term here is that term here. I won't worry about that right now, but that's this term here. So all I've done in going from this line to this line is taken the small b term and substitute for it. Notice that the h and the h cancel here. So I'm left with 2a minus hb over 2. And I've got 2a minus hb over 2. This is over 2. So I collect all these terms because they're both over 2. I get 2a minus hb right here. This is the minus hb. This becomes the minus hb. This becomes this minus hb. And this term becomes this term becomes this term. So the hb's cancel here. This minus hb and plus hb becomes 0. I have 2a over 2, and that becomes a. And if you look at the left side of the equation, it's a. So I've shown that the right side is a and the left side is a. So I get this. So here we have a formula that actually relates Fahrenheit and centigrade on a temperature scale. You may be familiar with this, you may not, but you don't really need to know that. We know that we're told that given centigrade, we can calculate Fahrenheit from this formula. We multiply the centigrade reading by 9/5 and add 32. So now, in this particular case, I have to solve this formula for C. I'm going to solve this formula for C. So multiply each term on the left and right by 5. Why do I do that? Well, I want to get rid of this fractional 5 here. So 5 times f gives me 5f. And then I'm going to multiply 5 times 9c over 5. I'm multiplying that. And then I'm multiplying 5 times 32. So I'm multiplying this by 5, this by 5, and this by 5. And you'll see that I get 5f, this 5, and that 5 cancels. I get 9c. 532 times 32 is 160. So I've cleared the 5 from both the left and the right side. Now remember that I'm trying to solve the formula for C. So I reverse the equation so that C is on the left. So 5f equals 9c plus 160. I move the right side of the equation to the left and the left side of the equation to the right. It's identical. Now I've isolated the C on the left because I want to calculate for the C. I move the plus 160 from the left side to the right. So the plus 160 becomes minus 160. This way I have the term 9c solely by itself on the left. Now I divide the left side of the equation by 9. I get c. I divide the right side of the equation by 9 and I get that. So I have c is equal to 5f minus 160 over 9. Now, to check this answer, I'm going to go back to the equation and I'm going to substitute on the right side for the c. Here's the c here, right here. Here's the c right here. I'm going to substitute for it in this equation. I'm going to start with the right side right here and reduce it so that it equals f. So you can see right here, I've got 9/5. Here's the 9/5 for the c. Here's the c right here. Here's the c right here, and I'm substituting for it right here. So here's c. Here's what I found for the c. And this 32 here is this 32. So I'm taking the right side of the equation. I'm substituting for this c right here and simplifying it. Notice that the 9 cancels. The 9 on the numerator and the 9 on the denominator cancels. I'm left with 5f minus 160 over 5 plus 32. So the 9 here and the 9 here is canceled. Now I can divide the 5 into this term and the 5 into that term in order to simplify it. So if you have a plus b over c, this is equal to a over c plus b over c. So I've got two terms here. I'm dividing by 5. I divide 5f by 5 and I get this. I divide minus 160 by 5 and I get minus 32. And then I have the plus 32, minus 32 plus 32 equals f. So now the right side equals f, the left side equals f. Oh, little error here. This should be equals. So there should be an equal sign right here. Okay, so let me just correct that right here, and I'm going to write it out. Left side, whoops, error in my typing, equals right side, period. And now I'm going to try and eliminate this here, this part here. Let's see if I can do that. There we are. Still got that little red dot in there, but I'll remove that later on. So left side equals the right side. Now we can use these formulas to check some assumptions. If you know something about your chemistry or your physics or your elementary science, we know that water boils 100 on the centigrade scale and 212 on the Fahrenheit. So let's say these are two temperature scales. Let's say we want to convert 212 Fahrenheit to centigrade using the formula we derived. So we know that centigrade is equal to 5f minus 32 over 9. So we just need to substitute the Fahrenheit in here in order to get the centigrade. We're converting 212 Fahrenheit to centigrade. So here's the centigrade on the left, given the Fahrenheit right here. So we put the Fahrenheit in. 212 minus 32 is 180. 5 times 180 is 900. So 900 over 9 gives us 100. So what we're saying is that 212 on the Fahrenheit is 100 on the centigrade. Okay, now let's try and reverse this. Let's assume we know that the boiling point is 100 in centigrade, and we don't know what the Fahrenheit is using that, using the formula given. So Fahrenheit is 9/5 centigrade plus 32. So for the centigrade, we put 100 because we're given 100 as the boiling point. And if we do 9/5 of 100, we get 180. You can say 9 times 100 is 900, then divide by 5. You'll get 180. Or you can say 5 into 100 is 20, and 9 times 20 is 180. So we get 212. This is just an aside to this. It just shows how we can apply a formula to a specific situation, and we try to do that in this case. So let's take a look at problem 3D. In problem 3D, we're asked to find the value of each angle. And in order to find the value of each angle, we have to find x. So if we have to find x, what do we know? This is a straight line. This is a straight line. So the sum of the angles is 180 degrees. So this angle in here plus this angle in here must equal 180. So we have 15x minus 20 plus x plus 40 equals 180, because this angle in here plus this angle in here represent a straight line, so they're 180. So now I'm just going to remove the brackets. Got 15x minus 20 here, plus x plus 40 here. It's nothing different from this line to this line, except that I've removed the brackets. Now I'm going to gather the x term on the left, 15x plus x on the left, and remove the minus 20 from the left, get plus 20, remove the plus 40 on the left, bring it to the right, and I get minus 40. So I have the variable on the left and the number on the right. 15x plus x gives me 16x. 180 plus 20 gives me 200. 200 minus 40 gives me 160. If 16x equals 160, I divide the left side by 16, and I divide the right side by 16. So now I want to check this. So what I'm going to do is substitute x equal 10 into this angle here. First angle is 15x minus 20. I'm going to substitute x equal to 10 here. I get 15 times 10, which is 150, minus 20 is 130. This angle is x plus 40. I'm going to substitute for the x. 10 plus 40, I get 50. The sum of the two angles, 130 plus 50 is 180. So I'm sure that I've done the problem right, because this is a straight line. Now the last problem on page 9. Here we've got two crossing lines, and vertically opposite angles are equal. This angle is opposite to this angle in here. So we've got an angle in here, and we've got an angle in here. We know they're equal. So this enables us to solve for x. 6x plus 20 equals 9x minus 13. 6x plus 20 equals 9x minus 13. Now I move the 9x from the right to the left. It becomes plus 9x on the right becomes minus 9x here. The plus 20 on the left becomes minus 20 here. I get minus 3x equals minus 33. 3x equals 33. X equals 11. So remember that if this is both negative, I can just multiply the left side by minus 1. I'll get this. Multiply the right side by minus 1, and I'll get that. And x is equal to 11. Now I'm going to check the answer. I know that this angle is 6x plus 20. So I'm going to substitute 6 times 11 plus 20. 6 times 11 is 66. I add the 20. I get 86. The right side is 9x minus 13. Substitute for the x. 9 times 11 minus 13 is 99 minus 13 equals 86. So I've shown that the left side of the equation is equal to the right side, and that this angle here, each of these angles actually is 86 degrees. There's actually the answer. The answer is that each angle is 13 degrees. So that completes page 9. So we're on page 10 now, and we're going to do 4 problems here. Problems that we're going to do are number 4, number 9, number 10, and number 12. So starting with number 4 now, we're asked to find the dimensions of a rectangle whose perimeter is 26 centimeters if its length is 1 centimeter more than double its width. So we start with the let statement, and we let x equal the width. We're told that the length is 1 centimeter more than double its width. So we're going to start by just saying let x equal the width. Now the length is double that plus 1. So we start with a simpler one. See, the length is a more complex one. The length is 1 centimeter more than double its width. So we start with the width as x and then define the length. So the perimeter of a rectangle, the distance all the way around is the perimeter. Right here, this is the perimeter, is 2 times the length plus 2 times the width. So we have that we've just reversed. We moved the right side, the left side to the right side and the right side to the left side. Then we remove the brackets by using the distributive rule. 2 times 2x gives me 4x. 2 times 1 gives me 2. I still have the 2x here. And this equals 26. So what we've done here, just to recapitulate here, we substituted for the length 2x plus 1 right here. Here's the length, and we know that the length is defined in terms of the width, 2x plus 1, and then the width is right here. Then what we've done is brought this side to the other side. We've reversed the side so that the variable is on the left and the number is on the right. We've used the distributive rule right here. So Now we say 4x plus 2x, leave that on the left, bring the plus 2 from the left to the right, change the sign. 4x plus 2x is 6x, 26 minus 2 is 24, so x is 4. Now let's check that answer. We know that the width is 4. The length is 2 times the width plus 1 equals 9. The perimeter is twice the length plus twice the width. Well, we know the length is 9. 2 times 9 plus 2 times 4. 18 plus 8 is 26. So we know that the answer is right because in the original problem is 26. So here, the key part is to define the original statement. And let's read it again. Find the dimension of a rectangle whose perimeter is 26 if its length is 1 centimeter more than double its width. So the length is more complicated, as I said before, but just to recapitulate, we set the x to width here, to the width, and then we define the length. The perimeter is twice the length plus twice the width. We substitute for the length, so everything is in terms of x here. Both the length and the width are in terms of x. And then it's just a matter of solving the equation and verifying the answer. Now, this problem here is we're told that at $7.50 per meter squared, how much would it cost to carpet an area 10 by 12 meters of a rectangular floor? So in this particular case, how much would it cost to carpet a 10 meter by 12 meter rectangular floor? So we know that area is equal to length times width. We've got 10 meters by 12 meters. This is 120 square meters. Area is always square in terms of square meter. When we multiply this meter by that meter, we get 120 square meters. Well, 1 meter, we're told, because when it says meter squared, this means per 1 meter. We don't put the 1 in, but that's what implied. If you want to buy 1 meter squared of a carpet, it's going to cost $7.50. So if I multiply, and I want to carpet an area 120, so to go from 1 meter squared to 120, I'm going to have to multiply by 120. So I have to multiply this 750 by 120, which will give me $900. So here, this is just to give you a picture of what the carpet looks like. It's 12 meters by 10 meters, and that represents 120 meters squared. And here, to visualize, here's not perfectly to scale. Here's a small piece of carpet that would cost you $7.50, because that's what you're told in the problem. $7.50 per meter squared. So here's this small carpet. And now you want to carpet a much larger area, 12 by 10, which is essentially 120 times as large as this. So you have to multiply the cost by 120. Problem number 10 on page 10. One side of a triangle flower bed is 3 times the shortest side, and the third side is 17 feet longer than the shortest side. So the first thing we do is make here's a triangular flower bed. Here's the shortest side right here, x. X equal the shortest side. That's the simplest one. Another side is 3x. That's what we are told right here. 3 times the shorter side. Well, x is the shortest side. Then the other side must be 3x. And we're told that the third side is 17 feet longer than the shortest side. So we take x and we add 17. So the perimeter is now the sum of the 3 sides. This side plus this side plus that side gives us the perimeter. So x plus 3x plus x plus 17 equals 67. And all I'm going to do here, going from this line to that line, is remove the brackets. I'm removing the brackets and bringing the 17 from the left to the right. So I get the 17 on the right. So I have the numbers on the right and the variable on the left. X plus 3x plus x is 5x. 67 minus 17 is 50. Divide this by 5, I get x. Divide this by 5, I get 10. So the shortest side is 10 right here. The second side is 3 times that. It's 30. And the third side is x plus 17, which is 10 plus 17, is 27. So if I add 10 plus 30 plus 27, I get 67. And that's what I'm told right here, 67. So the last problem on page 10 that we're going to do is to find the area of the end of the barn. Well, I looked at the answer in the manual to this, and I think the problem should read, find the area of the diagram shown on the right. So that's what we're going to do. We'll also find the area of the barn. So we're given this diagram here, and we know that if this is 30 right here, and assuming that this is a rectangle, this must be 30 up here. So we know that's 30. And so here we have this dimension as 40. So we really have the sum of two areas, a rectangle in here, and here we have a triangle. So we're going to find the total area, which is the area of the rectangle, and then the area of the triangle, which is this part here. So this is a rectangle, this is the triangle right in here. So the area of a rectangle is the length times the width, which would be 40 times 30. And the area of the triangle is the base times the height divided by 2. So I've made the base here the same as the length, if you would like, 30. 30 times 10 over 2. This dimension multiplied by that dimension divided by 2. That's this part of the equation over here. So essentially I said that the length is equal to the base, because I've used two different terminologies here, one L and one B. So now if I add these two terms together, the length times the width is 30 times 40. Base times height divided by 2 is 30 times 10 divided by 2. The 30 times the 40 gives me 1,200. The 30 times 10 is 300 divided by 2 gives me 150. 1,200 plus 150 gives me 1,350. And that way I've shown that the total area, the area of this is 1,200. The area of the triangle is 150. If I add the two together, I get 1,350. So this completes this topic, and we will continue with the next topic.